Hang 10 guys, I just gotta see if I can fix this issue. A bit of technical issues now. Once everything's fixed, I can do things. Okay, it seems to be live now. Just want to double check this issue. Yeah, seems to be working. Awesome, awesome. How will this work? Or is this going to cause me problems too? Okay, looks like we have music back. Restored that. Gosh. Okay. Yeah. I see that, right? Okay, I think everything's working now. According to Facebook, according to YouTube. No, hang on, almost there. So YouTube just needs to be fixed. And yeah, looks like we're live now, guys, finally. Okay, so let me go back into what I was doing before, okay, because I want to make sure that we're all on the same page. Okay, so let me open this up first. I need the desktop. I'll explain what happened in a second. Cool. Okay, so as it's loading. All right, welcome back, guys. I'm so sorry about that. Oh my god. So first issue, microphone wasn't working. Second issue, Australian internet. That's what we get. Yeah, so anyway, let me start again. Welcome to my live stream. So what I was talking about before, let me just get back into it. Okay, refresh myself. All right, so welcome to my live stream. I just want to say thanks to everyone who helped me get to this point. I've been trying my best to kind of perfect this, and it's getting there slowly. My only matter is I've got venue, I just need tech issues sorted, so I'm going to be working on that. Anyway, so like I said, welcome to the video. We're going to be covering in this video, hopefully I'm going to be covering in this video how to make an FPS controller, very simple FPS controller. So one that's not too over the top, extravagant, you know, with cameras and all that kind of stuff. I've literally consolidated this into its raw form, which is 2 scripts. One for the camera, one for the player. Now, the way that I've delved into this essentially is I've got the camera look script as tiny as possible, because all it's doing is it's literally just getting the camera to go up and down based on the camera movement, and also rotate the parent. So the parent is going to rotate only on the Y, so that way, and the camera itself is only going to rotate locally on the X, which is pitch. Yeah, so without further ado, let me show you this project. So basically what we're looking at here is, the fact that I've got this character controller, this player who it's just a simple capsule. That's all it is. And what the capsule is going to be doing is it's going to be having just the player script on it. It's going to have a character controller. So this is the bread and butter of what makes it work. Essentially, it's with Unity's built-in character controller. So what Unity's built-in character controller system, to my understanding, is it is a component that filters the way that the character's moving in 3D space. So using it, I think of it as a filter. I don't know, whatever you want to see it as. Yeah, so I see it as a character, a filter sort of ish thing component, because you use a script to interact with that component, this one here, and when you ask it to move is when you're asking it to check for like collisions and all that kind of stuff. So essentially, as a visual representation of what happens, basically you move the controller. As you're moving the controller, it detects well, you're asking this component to move in your script, and then what happens is if the character moves and hits an object, it'll do everything necessary to push it back, similar to how physics does it, although this isn't physics, and I'm going to get into that in this video, so you'll know exactly what I'm talking about. But yeah, as a high level, basically, we're going to be creating this capsule. That's all this stream is really going to be about, and that's using this player script as well as a camera look script. So the way the player is set up in the hierarchy is I've got the player game object, which is the capsule, and then I've got a main camera inside of it, and the main camera just sits right above where the head would be. So if I enable that, that's what it would look like. Look exactly like that. And apart from having a camera component and an audio listener, which is standard with cameras, you've got a camera look script, and the camera look script doesn't really do much, essentially just moves up and down and left and right based on your mouse input. So when I move my mouse up, down, left and right. So we'll get into that as well. Anyway, yeah, and then eventually you'll have a character controller that feels sort of like this. So I've got to disable the other camera. Hold on a minute. Disable, delete, same thing. No, it's not. I'll just delete. I'll just disable that. Okay, so if I hit play now, this is essentially what you get. So you get a character controller that feels much like this, and it's very simple. At this point, you can start to add extra things like pickups and interactables and maybe firing, so creating like a weapon or something. But yeah, so basically I also made it so that you can like change the gravity, you can change the jump height, and that will make it feel less floaty if you increase the gravity. So if I do that, check the player out in the scene view. So if I increase the jump height, sure, he'll jump higher, but if I increase the gravity, it'll feel more like a sharp jump because you're jumping up and then you're landing quicker. So yeah, you can configure it that way, and it's really, really nice and easy. So you can give that to a designer, they can go ahead and do it, or you can do it yourself if you feel like a generalist. Yeah, anyway, so the other things about this project that you need to know is the fact that I'm using 2 plugins. Plugin number uno is Boxophobic. Boxophobic is one I use very, very often. And the reason is because I hate the default Skybox. This just looks pretty. Look at that. So that's exactly what we're going to be going for. And just very simple environment. I'm not really going to focus on the environment too much. I'm only going to focus on the player. But yeah, that's Boxophobic. The other thing I am using, which I haven't used in this project, is ProGrids. ProGrids is a tool that lets you snap your objects to a grid. And it's really highly configurable. I do recommend it. However, Unity has 2 versions of this at the moment I'm aware of. One which is a plugin which you go to the asset store to download. I would recommend that one as opposed to the packages one that comes with a package manager, because Unity has one in the package manager as well. And as it's loading packages, I'll see if I can double check that everything's working on the stream, because I want to make sure I'm doing everything right. Yeah, so it's loading packages still, because our internet is pretty bad. Okay, let's see what we got. Ah, it's loaded. Okay, let me just double check everything's working. Yeah, okay, sweet. So it's working pretty well. Let's continue. All right, so yeah, so ProGrids, they have 2 versions. You have to go to show previewed packages because it's not really a final version. So if you go to show preview, it'll show all of them. ProGrids is the one that's here. That's a way of downloading it because you can just install it. However, I don't recommend this one for this version. I'm using 2018.3.0 F2. Now, unfortunately, this version here, for some reason, breaks every time. So just make sure that you use the one in the asset store. We're going to do that soon. All right, let's delve into it. So, let me see. Here is the project that I've already pre-sorted out. Let me just walk you through what I've done. I've just have an empty scene. I haven't done anything with the scene. So I've got first-person controller, I've got Pro Core, I've got Pro Skyboxes, whatever. Pro Core is actually ProGrids. Pro Core is just the folder. I think it's the name of the project, but anyway. Cool, so what ProGrids is this tool right here. And ProGrids allows you to see this grid. At the moment it's in 2D, so if I switch to 3D, there's this grid that you can use to basically snap objects. So an example of this is if I create an environment, which I'm going to do now anyway. So create an empty game object, call it environment, just to contain all my game objects because I don't want to get messy here. Okay, anyway, so this tool by default doesn't have this enabled. It's called snapping. If you turn it on, it will have the ability to I'm not pressing any buttons except for clicking and dragging, and it will snap. It'll start to snap. So now what I'm going to do is I've got the empty game object. Perfect. I'm going to create now a cube. The cube is going to be 20 units on the X, 20 units on the Z. So that way it's that wide. Just gives a character a place to walk and stuff. Just make some interesting level out of this. So I'm going to call it ground. I'm going to duplicate it. Call it platform. Move the platform somewhere, and then just shrink it down 5 by 5. Well, it's already snapping, so I don't have to worry about that. Thank goodness. Oh, what happened here? Okay, so because it's 20 by 20, it's not exactly on the units. It should be. I don't know why it's not. Oh, okay, it's half a unit. Cool. Yeah, nice. Okay, so basically, because I've set it to 5 by 5, it's got this extra padding. If I set it to 6, then obviously it's going to be touching and it'll look perfect. And now because it's 5, I can actually set this to snap to 0.5 instead. That's the beauty about Pro grids, is that you have it highly configurable. So there we go. I can just do that. Drag it up. Gives the player a place to jump. So there we go. Working in isometric. Ugh, I don't want to do that. Okay, there we go. So if I just place it there, duplicate that. Place one over here, maybe in the center. I don't know. I'm going to do something a bit different here. Just playing around with things at the moment. Duplicate these two. All right, let me just look at it as on the side view because I want to demonstrate jump. Jump is a really important factor of this because a character controller requires jump. Okay, so oh boy. All right, next. Now what we're going to do is we're going to create the player. But before I do, maybe I should fix this up. All right, so the naming is pretty off. What I usually work with in Unity, one rule I have in Unity, because this just makes me less going insane, is the fact that I just like to make sure everything's named correctly and ordered a certain way, so that way it's easier to find, it's also easier to work with. So it's I highly recommend doing that if you're not doing that already in your projects. Okay. So next, I'm going to be working on switching the Skybox out. So if you go to Window, go to General, or just go to Lighting Settings. Lighting Settings, I'm going to snap it over here. I'm going to click and drag the material in there. And I should automatically bake the lighting and everything with that tool. The beauty about this Skybox is that it's actually got a shader attached to it, which means, well, this material, sorry, has a shader, which lets you change a lot of things in it. Like, for example, it's gray at the moment, but if I change it to white, it becomes much brighter. Or like, if I switch the color over to something different, it becomes more interesting. So I might actually change the color for this project to make it look a little bit different. So if I just... That looks okay. Purples, that'll do. It's pretty good. All right, so now the next thing I'm going to do is make a capsule, and the capsule is going to be called player. So that capsule will be placed up here. All right, there we go. So we got that sorted. Next thing I want to do is I want to attach a main camera to it, which I can click and drag main camera, but it's probably just easier to create a new camera. When you make a new camera, all right, I learned this the hard way. So when you make a new camera, you need to make sure that you tag it main camera, because if you don't tag it main camera, when you try and access it through code, camera.main, it won't exist, you'll get null. That's only if one doesn't exist in your scene, I should have mentioned. So this one here already exists. So if I removed it, then now it's using this camera because it's the second one I have on there. So yeah, moving on, we've got the camera there. I'm gonna move it to 0.75 on the Y because it's local. So locally it's gonna be higher than what it was originally. So I'll do that. I'm going to also attach to the player a character controller. There we go. So we've got a character controller. So what a character controller gives you, it gives you slope limit, which is basically how high is the slope before it, how high can the player go up a slope before it stops. So the more slope you have, the more angle you have. If it goes greater than 45 in this case, because it's set to 45, then it won't let you go up that slope, which is pretty good because you can make like a open world environment or whatever and just have like walls be like really steep or something like that. So there's that. What else do you have? You have the camera. So the camera is, I'm going to delete that. The camera is not really going to change very much. I'm just going to add a script to it to get it to do things. So I don't really need to add anything else to it, I don't think. Double checking what's happening here. All right, so, all right, let's continue. So I've got some scripts I need to make next, but before I do, cool. So we've got 2 plugins. I'm going to fold that. Don't need it too much. I need to create a material for the player. That's right, because we won't be able to see what the player is. I'm going to change it to a different color as well. I'll just do it. It's green. I don't care. It's all good. That way we can actually see what's happening. I don't like the Skybox color. It's actually not that great. And I know that I always go with like blue, but it might be another color. Oh yeah, you gotta be very careful which colors you choose for this. I think darker colors work a lot better for this. Yeah, so we're back to square one essentially. All right, I'll leave it at that. I don't want to mess with it too much. We're just focusing on this anyway. Okay, so if I go to my folder structure, I'm going to create another folder which is called scripts. There we go. So scripts are here. I'm going to create 2 scripts. One's called camera look. The other one is going to be called player. Yeah. Okay. So there we go. I'm going to attach the camera look to the camera. Oh yeah, it's because I spelled it wrong. Okay. So what happens, which is really, really annoying, and I don't know why it's doing this now, because it shouldn't be spelled correctly. What is going on? I must have done something wrong. Oh, no, just didn't compile. All right, cool. I should have just let it compile. All right, so the camera look script is going to be attached to the camera on the player, and the player is going to be attached to the player. Wow, that's really easy. See, these namings, they're perfect. Okay, now if I go to that script, here we go, camera look. So what I've done, let me just show you the finished version. So the finished version has these 2 scripts. And essentially, there's not really much to it. I'm working with Visual Studio 2019. There's a few new features in it as well, so I'll go through that at some point. Basically, what the camera look does, let me show you what it looks like on this. So it'll give you the ability to hide the cursor. So when you hit play, you'll notice the cursor goes invisible. There's a way to do that in Unity. It's actually really simple values that you can use to change that. Okay, the next thing is you've got the speed. So that's speed on, it's not in like world units or anything like that. It's actually in degrees per second. So it's 120 degrees per second. So it's in angles. And the reason why it's per second is because I'm using delta time. So yeah, delta time does that. Okay, min Y angle, max Y angle is basically how much on the Y can you go in degrees. I've limited it to -20 and +80. I don't know if that actually does that though. Let me just double check. Oh, it does. Never mind. Okay. So there was a bit of an issue with it originally, but it's really good now. I'm happy that I went to that. Okay. So the next thing is the player as well. The player is going to have a few values, which is run speed, walk speed, gravity. But we'll get into that when we cross that bridge when we get to it. Let's do the camera stuff first. So we should get the ability to rotate the camera and stuff like that. And the way I'm going to do this is I'm going to create a public bool hide cursor. So what that does essentially is it checks is the cursor hidden. So it's a flag. I call it a flag. That's really just a true or false value. Sometimes other people call it flags. That's probably where I got it from. So yeah, I'm gonna basically tell the script that when you start the game, should the cursor be hidden, and just gives us control onto whether or not we want to do it. We need a vector 2 called speed because it's speed on X and Y. So that's why I'm doing a vector 2. So X. Per second. The next thing is public float min y angle, set it to 120, negative 120 f, and then max y angle. So if you didn't know, what you can do with C#, which is really cool, is you can do this thing where if they're the same type, float, you can just separate them by commas with this syntax, and it just creates two floats. Unfortunately, there is an issue with this that a lot of people aren't aware of. I'll show you in a minute. So let's go to make an Euler, so current degree rotation. So we're going to be recording how much rotations the player has, or the camera has, sorry. How much rotation the camera has at the current time, so that way we can adjust it. Okay, so back to what I was saying here. This thing here, the problem with this is that if you add, the only issue I noticed is that if you add a header and call it like, I don't know, angles, and because they're separated by commas, you can probably guess what's going to happen. If you're familiar with using headers just basically add this like bold text to the top of the thing. Wrong project. Okay, so I'm going to go to this. That's what happens. So it adds two headers instead. And the only reason for that is because of how the syntax works, and they didn't account for, Unity made this, the header thing, and they didn't account for what happens if people do commas. So yeah, if you are doing that, just do them separately if that's the case. Very minimal, but anyway. Okay, so the logic is, well, I'm actually just gonna write it, if hide cursor. So if we're hiding the cursor, we're gonna go cursor.lockState equals cursor.lock mode locked. So you're gonna set the cursor to lock mode. So this is basically lock the cursor. Is the cursor supposed to be hidden? Then lock the cursor, and then the last one is hide it. So we're gonna go cursor.visible, because you wanna hide it. All right, next we wanna get current camera angles, and that's by going Euler equals transform.Euler angles. Okay, so what this does, because I'm using Euler to represent the rotations, they're going to be in degrees, which means that transform.Euler angles, I'm getting the current rotation of the camera, just in case in the editor, if we rotate it and we want to check what it's going to be like from there, it won't snap to a rotation. It'll actually just be there. So we can work with that. Okay, and there's actually really not much to this, because I'll walk you guys through the logic, but I'm going to start to comment it first. So we need to get input from the mouse, which is like offsets. I'm going to call it input offsets. Next, we're going to rotate the camera using mouse offsets. Oh, sorry, input. I'll say input and speed. So we're going to rotate it by that. We're going to clamp the not y angle, the x angle really. I called it y angle, but the only reason why is because the mouse goes up and down and left and right in a different way. When you go up and down with the mouse, that's on the y. But in Unity, you want to rotate on the x, because the camera is being represented on a coordinate system that follows the x, y, z. And because I want to do a pitch sort of thing, it has to be on the x. So so essentially what I'm going to be doing is I'm going to be using the mouse Y to rotate the X angle, which sounds weird, but it's just because of how it's all structured. But yeah, it's just the opposite. So that just is, don't worry about asking why. Clamp function. So we're going to be using the, clamp function. So we're going to be using the clamp function, Unity's built-in clamp function. What that does is it allows you to keep it within a certain range. So to keep a number within a certain range. And that's on the X, and I'm just going to do it on the X. And lastly, last thing I'm going to be doing, I just want to make sure I got this correct. Okay, so the last thing I want to do is I want to rotate the camera on the pitch only, and rotate parent on your, which is Y, so I'm just going to explain it like that so we don't get confused. Pitch is X. So this is in relation to Unity. So Unity's pitch is on the X, and Unity's your is on the Y, which is that way. And then you got roll, which is Z, obviously. So there's that. All right, cool. That's all we're going to be needing for this. And I've got really simple syntax for this. So first of all, to get our input, or to get a mouse input, it's fairly easy. There's a thing in Unity called input axes, and I'll show you how to get to that. It's actually really, really simple. So get axes is actually referring to, and the text and everything is referring to a built-in system that Unity has, which is called, if I go to edit, oh, they've changed it. Okay, so go to project settings, it must be in there. I was familiar looking at it elsewhere. There's input. Input has a thing called axes, which is spelled differently, so don't worry about that. And inside of here, we're looking for mouse X and mouse Y. So if we look inside of it, it looks a little bit confusing, but basically what's giving me, what this value is going to be giving me is the direction up and down, left and right that I've moved my mouse from its last position. So essentially what it's going to be giving me is if my mouse is here, if I move up or if I move down, it's going to give me a positive or negative number. And that's judged based on this, so mouse movement. Unity's built-in thing. It's a really ugly system. They're going to change it from what I heard because they really don't like how this went through, but there's no one really working on it. So they're going to be changing this at some point. They've promised, but then again, they've promised this a while ago, so we'll see what happens. They are really pretty busy though. They've updated a lot of things in Unity. So constant updates, not too bad. Okay, so here we go. Float mouse Y equals input get axes mouse Y. That's it, we've got our inputs and they're in a float value. So negative 1 to positive 1. So to rotate the camera, I'm going to be rotating the Euler actually. So Euler.y plus equals mouse X times speed.x. So what is happening in this line? This looks so confusing, but let me just summarize it for you. So basically the way that you want to offset something, offset a number, is you want to offset it by a, if I could simplify this, you're offsetting it by a number, which if I move up and down, no, this is on the X. If I move right, which is going to be positive, that would be a positive 1, for example. 1 times the speed, so how fast you want it to go, and then you times speed by delta time, so times the delta time. Now, you might be thinking, hang on, how does BODMAS work here? BODMAS basically, if you're not familiar with it, it means which order of events happens first. Now in this case, it's going to go left to right. No, other way around. Right to left. Yeah, don't get confused there. Right to left. So it goes from here first. Now you might be thinking, but you're only timesing speed by delta time. Does that mean that it's only going to be for speed? Yes, you're absolutely correct. The reason is because if I times the whole thing by delta time, it's 1 times whatever everything else is in this case. Otherwise, it'd be -1 times everything else. So yes, you're correct. It is a bit of a mishap, but it won't make a difference because of the numbers that we have. It will in other things that you do, so just be very aware of that. So yeah, what delta time does as well is it just basically means that because I'm using this in update's happening per frame, which if my computer is really fast, it's going to be running at 60 frames a second. Now that can be a problem because if I'm running that one little line for 60 frames a second, it's going to be moving so damn quickly. So delta time, what that does is it fractions. It says only move Euler.y in this case a fraction of what the total would have been. Based on how fast my frames are going. So the delta time can be summarized as the delay or the time between frames. And it's usually, if you've got from memory, if you've got a computer that's 2.7 gigahertz in i7, you're going to be getting a number which is 0.03. So that's a number that usually comes up because every frame it depends on how fast your frames are running really. So it depends on how efficient the code is as well. So it's not really based on that. It's just I'm familiar with 0.7, so i7, which is 2.7 gigahertz. Yeah. So all right, cool. So Euler.x minus equals mouse y times speed. Now you might be thinking, why am I doing minus equals here? For the love of my OCD, why are you doing that? Well, the reason is because, okay, so because I'm doing pitch, and pitch is rotating positively up in Unity space. Unfortunately, because of how the operating system functions and how the screen renders from top down, unfortunately that's the problem. It renders from top down. So it means that Y is actually inverted for what I want it to do. So if I want to rotate up if I want the camera to go up instead of going down when I rotate up, then I would need to do minus equals here. Now, if you want it to go plus equals, that's fine, it'll work. It just means that your camera is going to be going the opposite way because it's like a positive negative thing. That's about it. Yeah, so coolios. When I finish this, I'm going to take a little bit of a question break. So if you have any questions, feel free to ask. Otherwise, I'm going to just take a second. But anyway, so what we'll do is we're going to be moving on to the clamping. So the clamping is where if the X rotation reaches a certain degree, I want to bring it back down. So Euler.x equals mathf.clamp. Euler.x min y angle max y angle. So what I've done, I'm just writing it and probably doesn't make any sense if you haven't seen it before, but let me just hover over it. So every function inside of Unity gives you, well, inside of C# really, gives you the option to read what each argument is. So the arguments I've given it is the value that I want to clamp, the minimum value it needs to clamp to, and then the maximum value it needs to clamp to as well. So minimum, maximum just keeps it within that sort of area. That's why it's called clamp. So it keeps the number between that. So that's basically it. That's all that does. It just clamps it between a min and max. And now we're going to start to rotate some things. So I want to rotate the camera first on the pitch only. So how I'm going to do this, the syntax I'm going to write for this, is local Euler angles. So local Euler angles is saying how am I going to rotate this camera locally. This is important to do local for this because when I'm going to be rotating the parent, which is the player, and when the parent rotates, it's also going to rotate the camera with it. So you don't want to rotate the camera based on Euler angles because then it's going to fight with the parent. Try it. I do recommend you trying it so you can see what I mean. So when you're doing this, just make sure that you can try each one of these. New vector 3 Euler.x. And also it just comes with, like, you know, if you're playing around with Unity and you want to play around with like some things, experiment. Just throw whatever it is in there. Like if you want to see what happens after I've written this and it works really well and then you want to try something else, do it by all means. You only learn by failing. So if it doesn't work out, fail faster. And I keep getting told that. So it must be true. Now, I'm going to rotate the parent locally as well. So when I rotate it, it's important to know that if I'm rotating the parent locally, it doesn't mean that I'm going to rotate the player, and only the player, not the camera. Local Euler angles means if it's a parent of something else, it's not going to, if it's a child of something else, it's not going to rotate the parent of that as well. Now, with local Euler angles, I'm going to be rotating it on the Y. So you see how I did this only on the X for the camera? So that means I'm going to be, you can probably see where I'm going with this. I'm only going to be rotating it on the Y, so Euler.y. Cool. So if you put them side by side, you'll see what I mean. So basically, on the camera, this is the camera here on the pitch, and then I'm going to rotate it on the X for the camera, and then for the parent, I'm going to rotate that on the Y. So that way the camera goes up and down, but then the parent is going to rotate on the Y, which means the camera can just rotate and look up and down and stuff when we move. That is it. That's this whole script. I don't really need much, so it's fairly simple. Now, if I go back, we can give this a test, and then we'll take a bit of a break. So if I hit... There we go. So that's what you should end up with. It feels pretty good, but the thing is you don't notice anything at the moment because the player's not actually rotating. The camera is, however. You can't see it either because I folded the components. So yeah, when you fold components, they don't show the visuals in the scene view. So if you unfold it, you'll see it. There we go. So there's the camera. If I rotate, it feels pretty good. It even has limits as well. So yeah, it's not too shabby. It is the best one that I've written so far. I've done this over iteration after iteration, so if you want to take a look at that and examine what I've done, there's so many ways to write this. You could even simplify it yourself. Mine, by no means, is the best. There are better ones depending on the situation. So if you're going to be building a MOBA style game, you obviously wouldn't use this camera, so you'd write something else. You could adapt this for that game if you want to do that. So yeah, it's up to you. All right, I'm going to take a bit of a break. Let's see what we've got. So, okay. Alright. Okay, cool. I have received a question about like whether or not this is on one of the streams. So one question I got given was, with the character controller, what kind of like settings do you have that will limit the player from moving a certain speed? Thing. We haven't gotten up to this yet. I'm going to go through it with you in a second. But basically, the way that you would do this is the speed is not actually. It's not actually governed by the character controller itself. It's your script. So when you call move on the character controller, it's going to allow you to move by an offset, and the offset is what you define yourself. So we'll get to that. It's called motion. I think that's the value they use for it. When we get into it, we'll see what it is. Yeah, we'll learn that together because I'm trying to figure it out myself as well. It's good to remind myself as well because I've done this that many times, but sometimes I forget certain things. All right, yeah. So that so far, what we've got so far is we've got the ability to rotate our camera in the game view. There we go. And it can go up, down, right, all that kind of jazz. Awesome. Now, we can move on to the player now. So we're pretty good to move on to the player. Let's go ahead. The player is gonna have... okay, let's just open the player. I want to show you what we're gonna do with it. Okay. So a few things. We're gonna start with the variables. So let me show you what the variables are that we're gonna use for it. I'll show you the finished product and what it would look like as well to play around with it. So if I play on the game. Okay, so the character controller at the moment allows you to move forwards, backwards, left and right, depending on which way you're looking. So that's something that I want to show you how to build. There's a function that lets you do this actually. It's designed for this purpose. So that whichever direction you're looking, that's a direction that you're going to be moving forwards, backwards, left and right. It's called world to local space. So yeah, if I forward, backward, left, right. So it's pretty solid. Next, we're going to look at these variables. So run speed, walk speed, gravity, jump height, ground rate. Yeah. I did get a question as well just now, which was with gravity. Is gravity defined in the character controller? Actually, it's not. It's like I said before, it's not a physics controller. So in Unity, physics is a separate component. It's called rigid body. So rigid body, that's not right. Let me explain that better. So rigid body is a component that you attach to a game object to tell the game object to be subscribed to the physics engine. Basically, it means that the object that you attach the rigid body to is going to have a physical sort of data associated with it. For example, mass, velocity, all that kind of stuff. Now, the character controller is not a rigid body at all, by any means. You might be thinking, but how do you do collisions? The character controller does it built in. It's actually got its own way of handling itself in the physics engine. It is part of the physics engine as well internally. I know because I've built one in the past, and it required like a character. That character controller was its own thing in the physics engine, from what I understand. I don't know how Unity's doing it, so I'm not quite sure 100%. But the character controller here is definitely not using the physics way of movement. It's using physics to do collisions, but that's about it. So, and also collisions is tricky too with character controls, at least from what I've understood with it. So I'll walk you through that as well if we get up to it. If not, that'll be another video. So it's all good. All right, let's look into the player script. So the variables that we needed were public float run speed, which is going to be set to, I didn't want to set it to 7.5. I set it to 8. Why not? 8 is good. I tried that out before and it was pretty good. So we'll do that. Public float walk speed. Walk speed can be something smaller than that. Oh, that'll do. I want to show you how to do the running. So running is when you hold shift and you move forward, it's going to speed up and stuff. Public float gravity. So gravity was 15. Yeah, 15. I should have done negative 15 because that way it goes down, but the way that I've done gravity in this game engine, in this script is a little bit different. It's not using like it's not using y. It's not like defining a y, so it doesn't matter. Public float jump height. So that's how high in units the character will be able to jump. Now, I say in units, but here's the problem. Because we're using gravity to affect this, I'm not going to do 20. That's silly. Let me do something different. 8 is good. So because I said world units, gravity is affecting this. So it might not look like it's going to 8. If you turn gravity off, it is actually jumping to 8. But then it won't come down. So yeah, keep that in mind, okay? It is going to be trying to offset by 8 units. And by the way, that's not 8 impulsively. So it's not 8, it's not going to jump to 8 units. It's going to gradually go to 8 units, which means that gravity will be affecting it and blah, blah. You'll get it when I get up to it. Okay, now before we get started, what we have to do is detect ground. Now, you might be thinking, character controllers already do that. Some people are like, when I use character controls, which is what I'm going to be running here, I need a reference to it first. And I need a vector 3 of motion, so how much movement are we applying to the controller? And this is the reference to character control. So we need to reference the component, the actual component itself, and the component is, I'm gonna close this. I actually don't really need this, so it's just using up space, screen real estate. All right, there we go, that's better. So basically what we're doing is we need to reference the component itself on the game object. So the component is this thing here. And how we're gonna do that is we're going to in start go controller equals get component. Character control. Now, I have a theory, and this is something that I haven't played around with too much. I do recommend it though. It's pretty good to do this. The start function itself is I usually do get components in awake, because the start function has the difference between awake and start is awake happens before start. Start will only run if the game object is enabled. Now, awake is the opposite of that. It'll run even if it's disabled. So it's going to always get component. My logic is that if you want to get component, you want to do it in awake, just because of the fact that if the game object is disabled and eventually you want to re-enable it, you'll want to get the component anyway. So I always do it in awake. I don't say you should do it in awake, it's up to you, but just keep that in mind. And also, I do highly recommend looking at this website Unity has done. Unity's got a thing called order of events. If you look up Unity order of events inside of like the actual page itself, if you open that up, it has a manual describing this. Basically, Unity has made a really nice overview as to which functions run first. So if you scroll down, they've got this graphic where they explain how all of the events happen in the game engine. Also, it's important to note, you've got to make sure you're in the right version. I'm going to switch to 2018.3 because that's the one I'm using. And hopefully it might be the right manual for it. Okay, wow, I have to search for it again. That's really nice that they didn't redirect me back to it. It was order of events. So now that I switched the documentation page to 2018.3, it should show the order of events for that version, because it's a bit different to the new one. The new one, they've made huge changes. And I just want to make sure I'm in the right version. That's the first thing I do when I go to the documentation. The documentation is only really good for if you want to get a refresher, like a reference to things. I highly recommend, they've got a second page. I always tell my students to look at this, but Unity's got a page which is, hang on, I've got to find it. Unity, there we go. So we've got the execution order of events. I'll get that up. But the other thing is Unity's got a thing called topics. So Unity topic list is introduction to advanced topics. Yeah, whatever. Let me just look up topics. It's usually in the Unity Learn. If you just look up Unity Learn. So if you look up Unity Learn, there it is, Learn Unity. They've got a tutorials side of the page, but they've hidden this very nicely, and I don't know why they've done this, but I want to find out for myself at some point. If I go to... They've changed the website so much. I want to look for tutorials. Oh my god, no, I don't want to do that. Alright, I'm just going to go to tutorials, because there was a tutorials part. Unity Learn tutorials. Okay. So in this page, if you scroll all the way down, they've got topics. Now, topics, don't worry about the tutorials too much, because the tutorials are pretty standard. Like they help you, they really do. But if you want to learn about nitty-gritty things, like specific things, you can learn about scripting. Scripting's pretty good. They're just a series of videos that they go through and describe how to use it at its bare bones, which helps you understand how to use it for other things. Physics, you can look into physics. That's a really good one. You also might want to look into, what is it? If I go into scripting, we might be able to find it. There's character controllers somewhere, so you can just search for it, but I highly recommend looking at that. So back to the execution order of events. If I scroll down, awake happens first. Start happens after that, but here's the thing. If you scroll up to where, or if you scroll down, I think, yes, down. This function is always called before any start functions, and also after a prefab has instantiated it. If a game object is inactive during startup, awake is not called until made active. So basically, what happens is the awake function won't be called unless it was made active, whereas start does. Oh wow, I got it mixed up. Sorry, I meant you want to use it in start. Awake is different. Yeah, I always get confused between the two. So yeah, awake is the one that you want to be careful with. So awake will be the one that you don't really want to have it in awake. You want to have it in start. So some people, I've seen people put it in awake, but you want to make sure it's in start because of the fact that if it's inactive, then it won't actually call it. So you want to always make sure that it's going to get a component. What you can use awake for though is if you wanted to do things like set a certain or search for something on enable. So when something is enabled, you want to search for it. You can do it in awake. So yeah, I do recommend doing that. But it does help to take a look at the documentation because I totally forgot which one was which. But yeah, start is the one that you want for this. So you just keep that in mind. Okay, so there's a controller. The controller is gonna have a way for us to do ground checks. So now the character controller comes with and is grounded, but it's very unreliable and I don't recommend it. So the reason why it's unreliable is because it serves a different purpose. It's not really supposed to detect constantly what the ground is. So we're going to be doing ground ourselves by drawing a line below the player and seeing whether or not it's hit anything. But that being said, I'm going to draw it out. So let's try doing this. Void onDrawGizmo. So onDrawGizmos is another function that comes with Unity, which allows you to draw lines and all that kind of stuff during the edit mode. So it happens in edit mode. Now, if I go to so what I've done is I've created an array. Create a array starting from center of player to the direction which is below the player. So this is going negative transform.up means negative whatever my transforms up is. They don't have transform.down, which is why I'm tackling it by going negative transform.up. Okay, so I'm going to draw the array. And that's by going gizmos of color. So I'm going to set the color to red so we can see it. By default, it's white, so you want to make sure that you can actually see it because the character, you won't be able to see it if it's for the ground. Now, the way we're going to draw a line, it asks where you're going to draw a line from and then to, so two separate vectors. Unfortunately, I'm going to have to go origin. Is the origin of the ground ray is going to be there, so ground ray dot origin, and then ground ray dot origin plus ground ray dot direction times ground ray dot distance. Now this is really tricky what I'm writing, but because I haven't actually got a distance variable, so I might do that quickly. You have to make a variable that we're going to be using for the distance, how far the ray is. It's going to be ground ray distance. I'm going to set it to 1.1f. That'll be perfect for that. Now, that's ground ray distance, so you want to make sure, let me just check everything is going okay. Yeah, it is. So ground ray distance is how far it is. It's 1.1 units I want to set it to for now. And I'm going to times this direction that I did before by ground ray distance. So what this line essentially is doing, it's going, okay, here's the, I'm going to do this in ASCII art because I'm not going to draw it. Basically, here's the origin point of where the line starts, but then you want it to go in a direction. So you want to go from start point to a direction and times it by speed, by how far it is, so distance. So it's origin plus the direction times the distance, and that means that it's going to give me the second point, which is that far. Okay, if you want to look more into it, I highly recommend looking at Wolfram Alpha. Wolfram Alpha is a really good site that shows you, visualizes how that works precisely. So I do recommend that. But let's see what this actually does, because we want to see what this produces. Alright, here we go. Here's the project. If I go to the player has all the variables that should show up now. And then if I hit play, I don't even have to hit play, sorry, because it's in scene mode. So if it's on Draw Gizmos runs during the scene mode, so it's during edit mode. So can you see that red line? It's hard to see it here, but if I drag it up, yeah, you'll see it. That red line. This red line is what I'm using to detect the ground. So it's just trying to detect if it intersects with the ground, and if it does, if I hit space, I'll be able to move it. Cool. That's about it for the ray. Now we have to do the actual physics part of it. We're just drawing it at the moment, so we're not really doing anything with it. Let's go ahead and do something with it. What we're gonna do. Okay, so I need a few balls. So private. Oh, actually, I might not need this because I have another way I was gonna do this, which would work better. Okay, so I'm gonna actually make a variable for this, but it's gonna be private. Private ball is jumping and is running. So I want two balls to detect whether or not we're jumping. So detect whether we're jumping or if we're running. And that's by using a ball. So the ball is a true or false value, if you remember. It starts as false by default. I'm pretty sure it should be false by default. Just double checking that. Yeah. Okay, now what we want to do is have a function which is called movement. What this will do, I'll comment it, it updates movement of the player. So that's this is actually going to be called an update. I don't really need like the movement function, but I did it anyway. I think the reason was so that I can run it outside. I probably won't need that now anyway, so I can simplify this further by just using update for this and getting rid of that. So yeah, I did use it originally for that, but I don't really need to now, so it's not a problem. However, I do need a public function. Oh, it doesn't have to be public. It could just be void move. And it's going to take in a float input h and a float input v. What this means, input horizontal, input vertical. So it's that's the standard that we use to describe whether or not we're moving in a up, down, left, right fashion, but we're going to be doing it forwards, backwards, left and right. That's the movement. So that's what this function is going to do. When we call it, it's going to start to move the controller. And we're going to get the controller to move based on our motion. We have a motion variable here as well, so we're going to be using that. Okay, so inside of update, I want to start this by... No, you know what? I'll start movement first. So how we're going to do this, I'm going to comment this. Convert input to vector 3. So we want to make sure that we can go vector 3 input. I think I can rename this to direction because this is technically a direction. I'm turning this into a directional vector, so which way forwards, backwards, left and right you're going. And the reason why it's forwards, backwards, left and right is because it's x and z I'm using it instead of x and y, because vector 3 is x, y, z. So yeah, just keep that in mind. We need to convert that direction to local space. I'm going to show you what the difference is with this on and off, but let me show you what this does. What this is going to do is it's going to make it so that your character is moving forwards, backwards, left and right, but based on the rotation of the player, you want to maybe move forwards, backwards, left and right in that rotation. So I'm going to be using a line of code to fix it, which is direction equals transform.transform direction. Weird name, but anyway, direction. So what this does, it filters this direction to convert it to whatever rotation my player is. If the character is running, then use run speed, else use walk speed. So we made two variables for this. Oops, consistency, there we go. We did two variables, so float current speed equals is running, question mark, run speed, else walk speed. So this is called a ternary operator. It's basically a one-line if statement. So ternary operator, and the syntax for this is condition question mark statement A else statement B, and then it returns that. So basically, yeah, that's what it is, a ternary operator. It's really useful for doing a one-line sort of thing, and it saves you a bit of code. So yeah, only modify the x and z values so y doesn't cancel gravity. So what we're going to do is we're going to be moving the character on the x and z only. We're not going to move it on the y because the gravity is going to affect the y, so we don't want to touch it. We only want to, actually will let us make it so that we can move the character as it's jumping. It's just like a slight movement speed you have to change it to though, but it will work. So the motion.x is direction.x times current speed. So whatever speed we're going to be doing that. Z equals direction.z times current speed. Now, you might be thinking, should I use delta time here? Motion is going to be used separately in another function very differently to how translate used to work, because we're getting the character control to move on an offset, but we are going to use delta time eventually for this. I'll show you where we're going to use it. But yeah, so there's that. Now, if I go to update, we want to check, is the character jumping? Is the player jumping or running? Question mark. Is jumping equals input, get button down, jump. Is running is input, get key actually. Key code left shift. So if left shift is pressed, then we're going to be in the running state essentially. And then we also want to get character in. Get input for movement. So this is float input h, which is what I wrote before, the variable that we're going to be giving this to, the function we're going to give it to. We want to get horizontal axes. What horizontal is and what vertical is, which is what I'm going to do next. Horizontal is A, D, or left arrow, right arrow. Should have done that. And then vertical is W or S, or up or down arrows. Yeah, so up or down arrows is where the thing is going to be. So yeah, horizontal, vertical is the arrow keys essentially. Now we're going to be applying movement. So apply movement. Whoops, that just looked like a ransom note. With input, okay, so move input H, input V. So what's really cool about this is that we could just fill it in like this and it will essentially move the controller. We'll try to move the controller. All it is just generating that motion for us. I can now start to add some things to this, which is when we're applying move, I want to make sure that we're also applying gravity and stuff. So maybe I should apply gravity beforehand. Yeah, okay. I might apply gravity here. So this is, I wrote it a bit different to what I'm doing now, so just bear with me. Gravity. So applying gravity to motion. Then we're editing the motion in here. No, okay. No, that's correct. Yeah, that's what I want. Okay, cool. I'm gonna leave it the way it is. And then that way, good, okay. When we're doing movement, and we're handling the way the character is going to move around left and right and stuff, it's basically move is just modifying the motion. So I'll say move is modifying motion. Okay. Now, what we're going to do after move, this is where it gets really interesting. We need to use the line, to detect the ground to see if we're touching the ground. And if we are touching the ground, then I want to make sure that we can do logic for that. For example, you can only jump when you're grounded. So that way, when you're landing on the ground, you can only jump when that's happening. So that's one thing. We're going to be creating an array beneath the player. I spelled it wrong, didn't I? I before E rule. I feel like that this is beating me now. Yeah, no, it's not even I before E. It's spelled like that. Okay, cool. I can spell. That's awesome. All right. So if I can make array, so array ground array. Same line we wrote before to draw it, which is important because like otherwise we're drawing a dud thing. So yeah, cast hit, or hit. Okay, so what this does, raycast hit will, when we perform the raycast, if you're not familiar with what a raycast is, it's literally just a way for us to draw a line in 3D space, and if it hits something, it's going to give us information about what it hit. If it hit on a certain angle, if it hit on a... I think it's really good for fixing a lot of problems with graphics, computer graphics. It's used in a lot of things. And it's everyone's go-to for fixing things, and it can get really messy, so just be in mind that there are other ways to do things without raycast. It's just in this case, I have to use a raycast for this. There's probably another way to deal with it, which is probably by using physics to detect if I'm hitting the ground, but this is using physics as well, so who am I to judge? If physics.raycast, ground ray out hit, ground ray distance. So let me explain what this is doing. Raycast has a few values that you can give it. One is the ray, the actual ray that you've defined already to go out from a direction. So a ray is literally going from the origin to a direction. And I know that because if you hover over a ray, it tells you origin, direction, and you give it that. So the transform.position is the position of the player, the center of the player, and then the direction is negative transform up, which is that way, because negative. So it's basically drawing a line going down. And we know that because we drew it out. So with a raycast, is grabbing that ray, it's trying to fill this with information because I've used the out keyword, and then the ground ray distance is how far is it going to be traveling before it hits something or whatever. It's how far this ray is actually going to travel. So yeah, that's raycast. Now if let's assume now in this function, if I hit something, we're going to cancel the y velocity if grounded, and that's by going motion.y equals 0f. So that means that, you know how I'm modifying the motion here? Which actually, it doesn't really matter which way I do this. I could even do it after here. It really doesn't matter. What does matter though is that I do the gravity stuff before this stuff, because if I do the gravity after, it'll look really weird. So cancel the y velocity if grounded. That just basically means that, see how I'm modifying the gravity here? If I hit the ground, I want that gravity that I've applied to cancel out. I don't want it to do anything. Okay, so if is jumping, which is jumping. Basically, that's the same thing. I didn't have to write that. So if the player is jumping, that's a better comment. Then we're going to apply movement in the up direction. Whoop, in the up direction. Motion.y equals jump height. So what this is doing, this is essentially saying that before we apply the motion to the character controller, I want to move the character on the Y by a height if I hit the space button, because that is jumping value is actually being set here. I could have just put this in here really, but I just wanted to store the input somewhere so we can use it for other things. So I could have just directly done this, but instead I'm storing it in a variable up here, so that way I can use it for other things. Maybe if I want to use it for checking if I'm jumping, I might want to not let the player move. Perhaps that might be a way to do it. And then very last piece of code we need is applying motion to character controller. And that's simply just controller.move motion times delta time. So what we're doing is we're telling the controller to move based on a motion, because if you hover over this, it's got its own move function. Now controller.move, that move function, is not the same as my function. I wrote this separately. This is in the player, and this is doing something very different. Now, the naming is important to make sure that you distinguish, because the controller is actually Unity owned. That's something that belongs to Unity. And because I'm doing dot, I'm accessing functions inside of that, which belongs to Unity. So if I go dot move, I'm essentially giving it a motion. And the motion, it says moving based on movement deltas. Deltas are, in this frame, how far are you offsetting? And we've done that by calculating it with delta time. That's about it. That's all you have to do for the player. That is literally it, I think. I think we're finished. Yeah, so the player controller is about 80 lines of code. Let's see if this works, though. I don't want to celebrate too early. I've done that before. Okay, let's see if this works. So what I expect to happen is I can look up and down, left and right, but then, oh, okay, I noticed a big difference, which is really good. Notice how the character is actually rotating this time. You won't notice it if it's set to global. Let me switch it. Okay, so the character is actually rotating. It's hard to tell because it's a capsule, and when you rotate a capsule, you don't really see it. It's just based on the shape. You can kind of see it with the edges because, unfortunately with Unity, because everything is, well, not in Unity, this is just in general, when you have a character, it's not a perfect, it's never going to be a perfect shape, so you're actually rotating a mesh. And that's what you can kind of see like the jagged edges when you rotate. This is just a thing that happens with 3D and games development. In graphics, it's because you're rendering points and stuff like that, you're going to notice that thing. So that's what that rotation is, but it seems to be working. It's rotating. Let's see if our movement works. Excellent. So our character can rotate forwards, can move and rotate in those directions. And we can jump as well. And depending on which way we're looking, we can also move in that direction. So I can jump on platforms now. And it feels pretty good. You can make a B-hop game if you want to. But there's so many of them already. Well, sort of. Okay, Okay, I want to show you one little thing. I did promise you guys I was going to show you what this did. So you see how it says convert local space for movement? If I comment that out, and what I just pressed to do this was Control KC, which means comment. If you want to do the opposite, it's Control KU, which is uncomment. So if I want to uncomment all of this, I highlight it, Control KU, and there you go. So Control KC, comments. Now if I go ahead and what we're trying to test at the moment is what that does when I move forwards, backwards, left and right. So at the moment you understand that when I'm looking in the forward direction, which in the world I think it's facing that way, that I'm looking right now. If I press W, I move forward. If I press S, I move backwards. If we press D and A, I move left and right. So now here's the problem, because I commented out that line. What that line was doing is that when I press W now, it's not going to keep going that direction. It's going to go forward based on where I'm rotated. So that line of code is actually really, really useful for doing this. All it does is it converts from world space to local space. So if I go like that, transform direction is going to convert that direction. If I look at the comment here, transforms direction from local space to world space. So it seems to be pretty solid. My mouse just messed up now. I don't know what happened. There we go. It was just Visual Studio. All right, that's about it. That's the end of the video. It was literally just showing you guys how to make a very simple character controller. Now you can add stuff to it. You can do whatever you want with it. And it's pretty good. If you guys have any questions about what we've done, feel free to ask, because I've got a part of my live stream is about Q&A, and I have Q&A, but I don't have any more questions. I think I've answered them all now, unless there are any left. No, doesn't seem to be any. All right, no worries. Well, if you guys have any questions afterwards, yeah, just go ahead. So yeah, thanks again for tuning in. Sorry about the whole technological issues, but thanks for bearing with me. We'll see where I can go with this in future. We can add a few more things. I'm going to be doing a lot more of these tutorials because I find them very sort of zen in my own way. I get to kind of talk it out and learn things for myself as well. It's one of the many reasons why I became a teacher, and I found it to be very beneficial for my own understanding, and also just asking questions as well helps me understand things. I'm by no means an expert. I don't know everything to the T, but I know enough to get me building things, and if there's something that I've missed out on, I learn from others. So yeah, if there's anything that you guys want to bring to the table, if you want to ask any questions and stuff like that, it helps me, and hopefully it'll help everyone else in the process. Thank you very much for tuning in, guys, and I'll see you next time I run a live stream. And hopefully we'll have way less issues. All right, ciao for now.